All right, geometry 3-2 statements, conditionals, and biconditionals. All right, remember so far we are doing basically it's basic logic. So this is another very wordy notes, and it's very, you have to think about it assignment. All right, so take your time, do it one step at a time. So today we're doing conjunctions versus disjunctions to start out with. Okay. Conjunctions, these are compound statements using the word and. Okay, and it is true only when both statements are true. And you will see it written like P and Q, or P, well, it looks like an upside down V, Q. So P and Q or P and Q. Okay? Now, disjunction, that's basically opposite, but not really. So it's a compound statement using the word or. And it's true if at least one of the statements is true. That's the or. So it's either or it could be both. So it's true if at least one of the statements is true. And it's written like this: P or Q, or P regular V, Q. Okay? So it's upside down V and or. All right? Very subtle difference. All right, let's practice. All right? So, example 1, truth values of conjunctions. It says use the statements to write each conjunction, then find the truth values. Explain your reasoning. Okay, so we have this shape here, and we have slash marks here, which means all your sides are congruent. Okay, so we have 3 statements. P statement is the figure is a pentagon. No, it's not. Statement Q, the figure has 4 congruent sides. Yes, it does. Statement R, the figure has 4 right angles. Yes, it does. Okay. So A, we are talking about statement P and statement R. So together must be both. So we put P and R together, and it says the figure is a pentagon, and the figure has 4 right angles. Well, that's not true. Statement R is true, yeah, but statement P is false. And since it's the word and, if one of the statements is false, then the entire statement is false. Okay? Now, this one, it looks a little different, okay? So it has this mark in front of the P. And that means not P, all right? So it's the opposite of what P is saying. It's called negation. Okay, it's called negation. New vocabulary word for us. Negation is opposite meaning. Okay, so the negation of P and Q. So the negation of P and Q, the figure is not a pentagon, very true, and the figure has 4 congruent sides, also true. So both the negation of P and Q are true. And since this means and, both of them had to be true, so the entire statement is true. All right. So that is truth values of conjugations. Conjugations is and. All right. with the upside down V. Now, truth values with disjunctions. Disjunctions is or the actual, looks like a V symbol. Okay, so let's check it out. It says use the statements to write a disjunction P or the negation of R. Then find truth of value. Explain your reasoning. So we have three statements again. So statement P, angle ABC and angle CBD are complementary. No, they're supplementary. Statement Q, angle ABC and CBD are vertical angles. Nope, they're adjacent angles. So neither of these are true. R says segment AB and BD are congruent. Okay, yes they are. They have the single slash mark, so yep, they are congruent. So P and Q are false. R is correct, is true. It wants us to do P or the negation of R. So that would read P statement, angle ABC and CBD are complementary, which we just said was false. Or segment AB and BD are not congruent because it's a negation of R. Neither one of those things are true. So it's false because P is false and the negation of R is false. So nothing was true. If just one of them had been true, we would have had a true statement because it would have been R, or. But neither of them was true, so we have a false statement here. All right, let's flip on the back. There's a lot going on back here, so we're going to take it one step at a time. Okay? Probably change color a couple times. So example 3, identifying the hypothesis and conclusion. Your hypothesis is if, conclusion, then. So these are if-then statements, your hypothesis and your conclusion. Wants us to identify the hypothesis and conclusion of each conditional statement. Okay? If-then, conditional statement. Conditional statement. This is your if-then. Okay? Because there's a condition to it. If this, then that. So it says, if a polygon has 6 sides, then it is a hexagon. Okay, so it just wants us to identify the hypothesis and the conditional. So the hypothesis a polygon has 6 sides. Then your conclusion the polygon is a hexagon. Hypothesis, conclusion. That's a conditional statement. If then. Okay? So we've taken a conditional statement and we've broken it apart to a hypothesis and conclusion. Okay? So now let's be given just a basic statement and write a conditional in an if-then form. Okay? So first we're going to identify the hypothesis and conclusion for each conditional statement. Then we're going to write it in the if-then format. So I'm going to change pen colors. Okay? So we have got 4 quarters can be exchanged for a $1 bill. All right, so let's talk about hypothesis of example 4. You have 4 quarters. Okay. Then, if you have 4 quarters, your conclusion is, let me see, we could exchange for a dollar bill. Your conclusion, you can exchange them for a $1 bill. Hypothesis, conclusion. Now let's write our conditional if-then statement. Okay, so if you have 4 quarters, then you can exchange them for a $1 bill. If, then. That's your conditional statement. If, then. All right. So if a conditional statement is an if, then, let's talk about some related conditionals. All right. So we have 4 of them. All right. So I'm going to switch to blue. So, community. It says each year Independence Day fireworks are displayed across the United States. 2013, 200 million pounds of fireworks were set off during independence celebrations across the nation. All right. So, first, let's talk about our conditional statement. Our if-then, okay? So this is our starter. So if it is Independence Day, then fireworks will be set off. All right, so that's our conditional statement. Okay. So let's do the inverse of our conditional statement. The inverse. With your inverse, you're going to negate both the hypothesis and conclusion. All right, so let's check this out. So let's make the inverse statement of this. All right, so if it is not Independence Day, then fireworks, I guess it helps if I put an E in fireworks, will not be set off. Okay, so we have our conditional if then, and then we have our inverse where we negate both the hypothesis and the conclusion. All right, so conditional and inverse are related to each other. And we have two more. We have two more, okay? So we are going to do our converse. So our converse, okay, we are going to flip the hypothesis and conclusion. Of the conditional statement. Okay, so of your original conditional, we're going to flip them. Okay, so it'll look something like this. If fireworks are set off, then it is Independence Day. Okay, so that is the converse of my original conditional statement. We just flip the hypothesis and the conclusion. One more, stay with me, okay? The contrapositive. Okay, the contrapositive. Okay, here's what the contrapositive statement. Contrapositive, okay, so it negates both your hypothesis and conclusion of the converse. Okay, so it's going to take your converse and it's going to negate both of them. All right, so let's check out this statement. If fireworks are not set off, then it is not Independence Day. All right, that was a whole lot we just did for that one. And those are all related, all right? So your conditional is your original if-then statement. The inverse, you negate both those hypothesis and conclusion. Then you can do your converse, where you take your original conditional statement and you flip that hypothesis and conclusion. And your contrapositive, you negate both the hypothesis and conclusion of that converse of your original conditional statement. I know it's a lot. And so let that digest. And we are going to move on to biconditionals. All right? Bi means two. Okay. So a biconditional statement is the conjunction of a conditional and its converse. So a conditional and its converse. All right? So your original if-then, and then the flipped. You're going to flip the hypothesis and the conditional and the conclusion. All right, so both have to be true. So you're going to get your conditional and then your converse of that conditional. And both statements must be true in order to be a biconditional statement. All right. So P leads to Q, and Q leads to P, then we can conclude that P and Q lead to each other. And what you get is if and only if. Okay, that's your biconditional phrase. If and only if. All right, so let's check out some biconditional. Okay? All right. First off, it wants us to write the conditional and converse for each statement and determine their truth values. If false, find a counterexample. Write a true biconditional statement if possible. So we have our original conditional statement here. And I know that because it has an if then. So if two lines are parallel, then they have the same slope and different y-intercepts. Now, my converse of that, we're going to flip the hypothesis and the conclusion. Okay, so the converse. If two lines have the same slope and different y-intercepts, then the two lines are parallel. All right, and then you look at them and you're like, okay, the conditional statement, if two lines are parallel, then they have the same slope and different y-intercepts. Yes, that is true. Yes. The converse, if two lines have the same slope and different y-intercepts, then the two lines are parallel. Yes. Both of these are true. So if your conditional statement and its converse, when you flip it, if they are both true, so if the converse is still true when you flip it, then you have biconditional. Two conditions. So, two lines are parallel. Here's your key phrase. If and only if. If. Key phrase here for biconditional. If and only if they have the same slope and different y-intercepts. All right. So if your conditional statement is true and the converse of that conditional statement is true, you have a biconditional statement you can make, if and only if. So last example. I know we've done a lot. So determine truth values of biconditionals. Write the biconditional as a condition and its converse. Then determine whether the biconditional is true or false. If it is false, give a counterexample. All right, so we have a biconditional and we need to break it apart now. Okay. So it says two angles are complements if and only if, there's the biconditional phrase, their measures have the sum of 90 degrees. All right, so we can make this a conditional statement. And this is all leading up to proofs, okay? So, if two angles are complements, then their measures have a sum of 90 degrees. True. And converse. So let's flip. If the measures of two angles have a sum of 90 degrees, then the two angles are complements. Are both these statements true? Yes, they are. If both, so we took our biconditional and we wrote a conditional statement, which is true. We wrote a converse, which is also true. And so that means that if both of these are true, then your biconditional statement also has to be true. All right, so this assignment, the assignment that goes with this, has some drop-down boxes. So in order to get credit on the assignment, you show your work, you just have to write down what you put in your drop-down boxes, and there may be more than one drop-down box per question. So write them all down. And remember, you have 3 tries to get each question right, and you can do the assignments a total of 3 times. So that means you have 9 shots to get it correct. So don't forget to show your work, and good luck.